Okay guys, we are going to prove the following theorems concerning a triangular numbers. There will be four theorems here, okay? Actually, those are not theorems, they are statements. All right, number one, prove or disprove that if n1 and n2 are triangular numbers, then n1 plus n2 is also a triangular number. So we know that 1, 3, 6, 10, 15, 21. Next would be 28, okay, 36. These are triangular numbers, which is a number that is a sum of consecutive numbers from 1, right, to the to that number of 10. Okay, so let's prove the first theorem. Is it true or not? Can can two consecutive no can two triangular numbers, then can the sum of two triangular numbers becomes a triangle numbers? Okay, so I can give you the, I think you can find the one that is not the case. Okay, so I want to let n1 to be 1 and n2 to be 3. Okay, 1 and 3 are triangular numbers. Then what happened? Okay, then n1 plus n2 becomes 1 plus 3, which is 4. But 4 is not a triangle numbers, right? It's not a triangular number. Okay, so we have we have n equal to 1 and n2 equal to 3, and the sum of these triangular numbers is not. So this statement is false. Okay, therefore, okay, 1 is false, right? So we disprove this statement already. Okay, next one, number 2. If n1 and n2 are triangular numbers, then the product of n1 and n2 is also a triangular numbers. All right, I can disprove this one, because when we try to, let's use a counting example. Let's use n1 equal to 3, right? 3 and 6, okay? These are two triangular numbers. Then, what is 18? n1 times n2 is going to be 3 times 6, which is 18. Is 18 a triangular numbers? Actually is not, right? Okay, because we have 15, and then next one we have to add by 6, so it turns out to be 21. So 18 is not a triangular number. Okay, it's not a triangular numbers. Okay, so statement number 2 is false. Now the third one, you may use another examples. Okay, you may try to use 6 and 10 or 6 and 15. All right, let's go to the third one. The third one is, if n is a triangular numbers, then 9n plus 1 is also a triangular number. Okay, when n is 1, this is 10, right? Okay, try to write something. When n is 1, 9n plus 1 is 10. What about the next triangle number? When n is 3, so 3 times, 9n plus 1 becomes 28. 28 is a triangular number, right? when n is, what's the next one? 6, okay? 6. 9n plus 1 becomes 9 times 6 plus 1, 55, okay? 55. 55. Is 55 a triangular number? So we're going to have 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 8 plus 9 plus 10. 55 actually is the sum from 1 to 10, right? Because these are 11, 2 plus 9, 11, 5 plus 8, 11, 11 and 11. We have 1, 2, 3, 4, 5, 5 11s, okay? It seems that, okay, next one is 10. So it seems that if n is a triangular number, 9n plus 1 is also a triangular number. Okay, this is the conjecture for this. So it turns out to be 9 times 10 plus 1, 91. Okay, 91. Is 91 a triangular number? I'm not sure. Okay, but we have to prove it now. We have to prove this theorem. Okay, so let's try to prove this, because I think that this statement is true. Okay, so we let n be a triangular number. Let n be a triangular number. Then what do we have? Okay, so there exists a positive integer, let's say k, okay, such that when n is a triangular number, n turns out to be maybe 1 plus 2 plus 3 all the way to n, all the way to k, right? Which is turns out to be k times k plus 1 over 2. This is the formula of the sum of consecutive number from 1 to k. Now, this is our n. What happened to 9? Okay, 9n plus 1. What is it? So we multiply 9 and plus 1 here. So it turns out to be 9k times k plus 1 over 2 and plus 1 right there. Alright. So we try to write this equation so that I think we try to have this one in the form of a triangular number. Okay? So let's do it. So we're gonna have 9k squared plus 9k plus 2 over 2. Okay? And then what I want to do is to try to have, I'm gonna try to have complete square, because we have 9k squared plus 9k. So it turns out to be 9k squared plus, I can decompose 9k into 6 and 3. So we have 6k plus, decompose number 2 into 1 plus 1. So it turns out to be 1 plus 3k plus 1. Okay, divided by 2. And this one right here is a complete square. So it turns out to be 3k plus 1 square plus 3k plus 1 over 2. Then what do we have? We're gonna have 3k plus 1. I will factorize the 3k plus 1. So we're gonna have 3k plus 1 times 3k plus 1 plus 1 over 2. Alright? So it seems that we are going to have the sum of what? The sum of consecutive numbers from 1 to 3k plus 1. Right? Okay? So we're gonna have 1 plus 2 plus 3 all the way to 3k plus 1. Alright? Okay? So is this a triangular number? Yes. Okay, this means that 9n plus 1 is also a triangular number. If n is a triangular number. Okay? So let's continue. So since we know that 3k plus 1 is a natural number, because when k is a natural number, multiplying number 3 is also a natural number. And natural number plus 1 is a natural number. So when n is a natural number, we're going to say that there exists, okay, natural number Q such that Q equal 3k plus 1. Okay? So, what happened to 9n plus 1? 9n plus 1 becomes, okay, 1 plus 2 plus 3 all the way to 3k plus 1 become Q, right? I just want to change it into Q because I want just to simplify it. So it turns out to be Q times Q plus 1 over 2, which is the formula of the sum of the sum of consecutive number from 1 to Q, which is a triangular number. Okay, so we have proved that when n is a triangular number, 9n plus 1 is also a triangular number.